Welcome, everybody. This is From Zero to Production in Kubernetes. I'm Josh. With me are Javier and Jason from NGINX F5. A little bit about the prerequisites for the stuff that we're displaying. You'll need a copy of the Mara code. It's open source, so no worries there. Just go to nginx.com/Mara and go ahead and clone it. You'll need a Linux workstation or VM, but I believe Mac OS is good as well.
Provided that you are running a Mac OS on Intel, you should be good. We're having a few problems with Apple Silicon. We're clear 100% on Intel. We have some Python compatibility issues with the M1 architecture.
Very interesting. Okay, cool. All right, so good. All right, so yes, do this on Linux. You'll need an AWS account. You'll need a Pulumi account. Pulumi accounts are free. And you'll also need Python 3.9 with virtual environment support. So I'm going to hand off to Jason now. He's going to tell you a little bit about Mara.
All right, thanks, Josh. The Mara project. Mara is something that we started almost 2 years ago now. We were approached by our business unit and asked to talk about what a modern application would look like. When we talk about modern applications, what are we talking about? And it became abundantly clear as we all started talking together that the application is only part of the overall stack. And we use the iceberg metaphor here because underneath that application we have monitoring and observability and management. Somewhere down there there's Kubernetes. Somewhere there's actual hardware that's running all of this. So what we like to say about Mara is that it's an example architecture using Kubernetes that aims to be as production ready as possible. So this is our greenfield deploy of a modern application on Kubernetes. So why did we build this? Well, the team that Javier and I are on, the Community Alliances team, we have experience across the breadth of the IT world. So we have former operators like myself, we have developers like Javier, we have QA folks, we have folks that are in documentation, pretty much the entire gauntlet of what you do in a modern IT department. So we wanted to take all of our experiences and build a best practice example. Second, as we went through and started looking into modern applications, we found a lot of anti-patterns out there. And by that, I mean demos that require a bunch of licenses, trial licenses, or what have you, demos that actually don't work, demos that are basically a very fluffed up marketing pitch. So we wanted to avoid those anti-patterns. And most importantly, we wanted to highlight open source as a core part of the modern applications. The core is open source. There are proprietary pieces that go on top, but at the bottom, it's open source. So how do I use Mara? We're going to do this today in a short little video I have showing a deployment, but it's supposed to be simple. You clone the repository, you have your credentials. Today we're using AWS. You could also deploy to DigitalOcean. You can deploy locally to a workstation-based Kubernetes. You run a setup script, you run a startup script that asks you a number of questions, and Mara will be up and running. The goal was to make it easy for people to bring it up and run it. Now, how are we supposed to use this? Well, you can run the whole project. You can take it, you can run it, it'll come up, and we'll show you in a few minutes. This is what Mara looks like. Here's the application. Here's the data flowing to our observability. But also, it's designed to let you review patterns. Let's say you want to figure out how to instrument your applications with OpenTelemetry. You can look and see how we did it. You can question us. You can go to our GitHub repository, raise an issue, open a discussion, and ask us questions. Why did you choose this pattern? We're not always right, and we're willing to listen to the community input and make changes. So you can review the patterns and use them, or you can lift the code from it. We don't recommend that you run Mara as is in production, but you can take the code and work it into your own solutions. So finally, who runs Mara? What are the use cases we see out there? Well, for developers, it's a way to stand up an application. They deploy Mara, and instead of our bank of Sirius application, they go ahead and set up their own application. As an operator, I want to understand how I manage my installation, how I deploy things, and how things break. What are my failure modes? What do they look like? The QA engineers on the team like to have a reproducible test environment. You can spin up a new Mara environment, do your testing, tear it down, and spin up a completely new environment that's guaranteed to be the same as the previous one. And then finally, vendors and projects. One of the things we're going to talk about with Mara is how it's a pluggable architecture. Each section is a different Pulumi project. So what we can do in this is we'll be deploying Elk, we'll be deploying Grafana, but we also can deploy Sumo Logic. We also can deploy Lightstep. So vendors can plug their components into Mara to use them, show them off, and see if they work. And with that, I'm going to send you back over to Josh to talk a little bit about Pulumi.
All righty. So a little bit about Pulumi. First off, we definitely encourage everyone, if you haven't created a Pulumi account yet, it is free, and we definitely encourage you to do so. So creating a Pulumi account will allow you to use the Pulumi service backend. And what that will do is it will manage your state file for you, and it will also handle secrets encryption. So Pulumi does not write any secrets to your state file in raw text. It's always encrypted. So Pulumi service will do that for you. There are other other options for that. So you can use S3 and like KMS if you're in an AWS environment. But for at least for just to get started, using the Pulumi service is going to give you like the smoothest experience. Yeah. So if you don't have an account, please do sign up. If you you're at the point where you have used Pulumi for a little while and are comfortable doing so, we definitely encourage you to sign up for a 14-day free trial. There's no credit card required, and it gives you access to like all of our features, like including like the top end like enterprise stuff. So, so definitely sign up for an account, give it a go for a little while. If you think if you're having a good time and you want to potentially expand your usage of Pulumi to your organization, do also try the free trial. Individual use, it's free forever. So you don't need to worry about any of that. It's basically at the point that you need to collaborate on a team that use of the Pulumi service would incur a cost. So when you're learning Pulumi, definitely sign up for an account. It's like the easiest way to get started. Okay, so what is Pulumi? Pulumi is an infrastructure as code tool that allows you to use real programming languages, and it works with pretty much any cloud out there. So when we say real programming languages, you can write your infrastructure as code using Python, which is what we're going to be using today. You can use TypeScript or JavaScript with Node. You can use the .NET languages, including C# and F#. You can use Golang. We have Java that's in preview, and we also even have a YAML option, which is kind of like a baby steps way to onboard to Pulumi. In addition, we have a wide range of providers. The providers are the things that allow you to control the resources in a given cloud. So, for example, we have an AWS provider. We have an F5 big IP provider. We have a Kubernetes provider. We'll definitely be using the AWS and AWS and Kubernetes providers today. Pulumi, as on the whole, is open source. The only part that is commercial is the SaaS backend. That's the Pulumi service. But you can use Pulumi in an entirely open source way if that's what you want to do. A little bit about Pulumi's program model. So at the top level, we have a project. You don't really deal with projects that much directly. You kind of like when you initialize a Pulumi project, you're basically initializing a program and a stack. So I'll describe the program first. That's where your code goes. That's where you are defining the resources, the infrastructure that you want Pulumi to manage, for example, like a Kubernetes cluster or an AWS S3 bucket, things like that. So within your program, you're defining resources. Resources have inputs and outputs. An example of an input would be like the version of Kubernetes that you want for an EKS cluster. And then resources also have outputs. So let's take a very simple example where we have an AWS S3 bucket, and then we want to define a policy for that bucket. we're going to define the AWS S3 bucket as a resource, and we're going to use its output, which is one of its outputs, which is its ARN, and we're going to feed that into the bucket policy. And so through these uses of inputs and outputs, that's how Pulumi internally keeps track of what depends on what and what needs to be created, modified, or deleted, and in what order. So resources, inputs, and outputs, if folks are familiar with promises in JavaScript, they behave very, very similarly. Most of the time, you don't even need to worry about the fact that you're dealing with inputs and outputs, as you'll see when we get into the code a little bit. In addition to the program where we define our resources, we have stacks. And stacks are basically instances of our program, and then they might differ by configuration values. So like a common use case for this is we might want to stamp out a dev environment, a QA environment, and a production environment. And we might want those environments to differ a little bit. So we might want to use like maybe a smaller Kubernetes cluster that's running on like less powerful hosts in our dev environment than we would say in our production environment. And so we can add configuration to our stacks that would feed into our Pulumi program to help define the like right resource sizes that we need. So that's how stacks work, and that's essentially the Pulumi program model. A little bit about Pulumi's like architecture. So in the bottom left of this slide, you can see that we have our Pulumi program. That's again where we're going to be defining our resources. We're going to be using Python for that today. The Pulumi program is run by the Pulumi engine. The Pulumi, and actually, we're going to even flip the script on this a little bit because we're using a little bit more advanced thing called the Pulumi Automation API, which I will describe in a minute. But in a simpler Pulumi program, you have the Pulumi engine, and that's going to interpret your program. It's going to check with in this case, the Pulumi service, although you can use different state backends, to say, hey, what exists in reality, and what did you want to what do you declare to be in your Pulumi program? So Pulumi programs are declarative. You only have to say what you want the state of your infrastructure to be, and Pulumi will figure out the steps necessary by diffing versus the state file as to like what actions actually need to be taken against the cloud provider's API. So if you say, I want 4 worker nodes in my Kubernetes cluster, and there are 3 in reality, the Pulumi engine will be able to figure out, hey, I need to add 1. If you wanted 4 and there were 5 in reality, the Pulumi engine would figure out, hey, I need to delete 1. And the way that it does the work against the cloud provider APIs is through the Pulumi providers. And so that you can see on the bottom right, we have AWS and Kubernetes specified, but Pulumi works against a wide range of providers. And to see the full range, I will throw a link in the handouts once I'm done talking that will send you to the Pulumi registry. And there you can see the sort of full breadth and depth of the providers that we have available. All right, so now I can hand back to Jason, and we can get started with the code.
You can go to nginx.com/Mara, which is a convenience URL that'll put you into this repository. And we just want to talk through this at a high level. As I mentioned, this was a project to create a fully deployable Kubernetes application, a modern app including management and monitoring tools. And when you go to the repository, you will be met with what we consider a modern app to be, what our architecture looks like, what's being built. And again, as I mentioned when I started, please do interact with us in the discussions or the issues. Please do talk to us in the community Slack. But let's take a look at some of the actual code. The first thing I want to talk about is the automation API. Josh mentioned this, and this is a very powerful piece of Pulumi that we managed to move to probably about 6 to 7 months ago. Initially, what we were doing is writing a bunch of bash scripts to stand things up and tear things down. But with the release of the Pulumi Automation API, we went through and changed things so that we have a Python program that is basically following Python best practices and going through and calling out to the necessary infrastructure providers. So in this case, we're just showing how AWS works. If you're interested in the decision to move to the automation API, how we use the automation API effectively, this is a good place to read through to understand what our assumptions were and what we did.
Yeah, so just to explain the Pulumi automation API a little bit deeper. So normally when you run a Pulumi program, you're going to run Pulumi new, right? And it's going to scaffold out some stuff, including an _ main.py. And the way that you execute that program in Python is that you run Pulumi up, and then it will find that main and it will run it. When you use the automation API, you actually flip the dependency and you're embedding Pulumi in just a regular old Python program, and you can do all the Pulumi command line stuff programmatically within just a regular old Python program.
So here what you're seeing is this is where we go through and iterate through our providers. And we've taken care to do things in such a way that providers can be added. So right now, we're going to do AWS today. We also deploy against Linode, DigitalOcean, and we also have deployments against just kubeconfig. So if you're running micro K8s, if you're running K3s or minikube, you can deploy against that as well. But here are all the files that do the calls to stand up our infrastructure. So more specifically, when we get to infrastructure, you can go through and see. So here is AWS, which we're going to be showing. So here's our VPC, here's our Kubernetes installation, here's our registry. And kind of to talk about, what advantages Pulumi offers. This is Python code, and this code is going through and using the Pulumi Kubernetes provider to stand up our stack. So at this point, let's go ahead and take a look at the deployment. So this is going to show us deploying Mara against AWS. To get started, you just go out and clone the repository. Once you've cloned the repository, since we are using Python, you're going to go ahead and need to set up a virtual environment. And just a quick note at this point, everything you're seeing here has been accelerated. Currently, a full AWS stand-up of Mara takes on the order of 30 to 40 minutes, with most of that time being spent doing things like deploying EKS. So we're speeding this up, but here's us deploying our virtual environment. Javier has been involved with this. One of the issues we've been running into is versioning for Python, making sure that every Python version works with what else we're deploying. Once you've stood up your virtual environment, we go ahead and actually call the runner command. This is the Python program that calls the automation API. So in this case, we're using AWS as our provider. We're calling our stack Mara test 05. And now it's going to ask us some questions about what our environment looks like. Where are we deploying? How big of an EKS cluster do we want? What version do we want to use? How many nodes? Once you've answered this once, you can tear the environment down and back up, and it won't ask you a second time. It's building out its Pulumi configuration file right now. We also ask some password questions for the application itself. And once you've given it all the information it needs, now we start deploying. So we deploy the VPC, we deploy our Kubernetes, and then at this point, as we go forward, we're going to see other parts of the stack being stood up. Josh mentioned Pulumi's secret store. The way we handle secrets in Mara is you put them into Pulumi, and then this project here is going to go through, create a secrets project, and it's going to go ahead and store those secrets as Kubernetes secrets to make sure everything in Kubernetes can grab them. So here's the secrets projects going through. And you see we're getting a bunch of information back, and we're going to go to the back end, the Pulumi SaaS, and look at this because we can view this there as well. One of the additional benefits that we have in this project is we build our own Ingress controller. You can use the off-the-shelf NGINX Kubernetes Ingress controller, or you can build your own version with custom modules, with custom code. So our stack goes through and will build it for you, and then it pushes it to the Elastic Container Registry where we can then pull it later. And now we're going through and setting up the Ingress controller. This is where things are getting set up. Javier, do you have any thoughts you want to talk about at this point?
Well, I mean, I think that this kind of thing, like going through and being able to see, going back to what you were showing with the automation API, the part that's I kind of came into this project in the middle, and one of the things that's been nice for me is I come from more of a development background, so actually reading Terraform isn't part of my natural skill set. I kind of have to strain to do that, and so going through and being able to see, okay, here is a AWS piece that I know, and I can see it represented as code where we're kind of sequentially going through and saying, okay, given this set of configuration that you saw Jason set up at the beginning of this, here's how we're going to set up, for example, the Elastic Container Registry. And it's kind of, it's something I wish I had, because I spent a lot of time banging my head against Terraform as a developer, because I worked at a place that kind of foisted that on us. And so that was a thing that coming into this project, being able to go into each folder and have a file that said, okay, this is the Elastic Container Registry set up, and having it be expressed like step by step, create the Elastic Container Registry with these options. Now we have an object that represents the container registry that we can then pass to other things and, get things like the Amazon resource. I'm not sure what the N stands for in ARN, but the ID essentially of that, and have them be able to use it. That's been really interesting. The other thing that this kind of reminds me of that has been really helpful. I mean, Jason, you talked about starting up test environments and having them be clean and reusable. This is something that in my previous work at other companies with microservices was really beneficial, where we'd have a team that was doing changes that spanned multiple applications that needed to be tested together in an integration test. And a lot of companies use shared integration environments for this. So you're never quite sure what's going on. You can do your best to manage it, but you're never sure it's a clean environment because there's other folks using that integration environment. But we had a place where we could say, all right, I would like to set up a clean environment that's just for me, that has this change to this application, this change to this other application, and then spin that up, and it's yours, and that it contains exactly the versions of each service that you were developing to create your change. And then you can run your tests, and then you can decommission that environment cleanly and start it again if you need it. So that was something that from the development perspective was hugely helpful that I haven't seen anywhere else. And this is the type of thing that you could easily accomplish with Mara and the automation API.
Thanks, Javier. So we've reached the end of the stand-up here. The final thing that we stand up is the Bank of Sirius application. The Bank of Sirius application is actually a fork of the Google Bank of Anthos. And we chose that application to kind of be the highlighted application in Mara because it's a polyglot application, it's microservices based, and it's not the world's best application. It has flaws. We wanted to be able to put something out there that we could then work on and fix and make better. So what we've done is we forked it, and we've gone ahead and de-Googled it. So all the things that tied into Google Cloud have been taken out. And our last big update to it added OpenTelemetry tracing to it. And as you watch things stand up, you probably saw the observability section go through. With Mara, we've started to go pretty heavy in the direction of OpenTelemetry. This version you're seeing right now stands up a log store, which is Elasticsearch. It uses FileBeat, it uses Prometheus, and those are all pretty heavy. And honestly, one of the biggest, if you're watching your cloud spend, or if you need to make buy with less, the weight of the Elastic stuff being stood up is one of the more expensive parts of Mara. So we started looking at OpenTelemetry, and one of the integrations that we'll be speaking on later this week is an integration with Sumo Logic, which sits on top of OTel for logging, for metrics, and for observability, and allows us to take out the Elastic components, take out FileBeat. Once everything's stood up, at that point in time, we can go ahead and look in it. Now, a tool I use is NGINX. It's a curses-based console application that allows you to get in and look at things. But I want to go here and look and see what's my endpoint that I need to go to. So that's my Ingress. And I can look in the namespaces and figure out what I'm doing. For this, I want to do things like I want to forward ports. We can do this with the kube proxy, the kubectl. Again, I just find K9S to be a little easier to use. So here we're going through, we're forwarding ports, we're making sure that we're able to get into everything. I do see a question there about Mara for other cloud providers. We accept pull requests. We have a limited amount of bandwidth on the Mara team, so we kind of focus on the big clouds, but we're always happy to work with it. Here we see the Bank of Sirius application running. It's a real application. You can make deposits. You can do everything that you could do in the Google Bank of Anthos. And then we're going to go take a look at Grafana. From Grafana, we can go in, we can take a look. We can add dashboards to it. We can pull up information on our installation. Again, the goal is to make Mara be as functionally complete as we can. And again, this is all being stood up on the back end by Pulumi. And then finally, here's us using the load generator. This is called Locust. We have a plan inside the project. And this goes through and allows us to generate a load. This is where, if you want to do some stress, or if you're an ops person, you want to do some stress testing, you can just keep cranking up the load on the application and see what breaks. And then from this, we can go ahead and look and see what our logging is pulling in. So I'm going to go ahead and stop this now, and I'm going to pop over to my web browser to show you a few other aspects of Mara here.
And while you're doing that, I just want to say that the stuff that you showed with setting up the Grafana dashboards and having the log organization and all of that stuff, there's all these tags that go into it. It's easy to say, kind of going back to the iceberg, it's easy to say, when you're setting up a new service, the things that you need at the most basic level is you need logging, you need metrics, but inside each one of those things are 1,000 tiny decisions that will slow you down. And having had to go through this process as a developer before, even if you're not setting up the whole Mara, having a place to go in there and say, okay, well, I've got a Python application. How are you getting these specific tags? I want to make sure I get the VPC host name into all of the metrics that are getting pushed into my Prometheus or Grafana. And then I want to experiment with how that helps me. And when you're doing that from scratch, that's a huge time sink that a lot of people who are working on projects don't anticipate. And so that's what I found helpful, is to be able to go in there and say, okay, this is how they're getting that tag into there. And then this is how I can kind of play with it in Grafana. And then I can make a decision about whether that's right for my project or whether I need to use a different pattern.
Yeah, and that, what Javier is just describing is kind of one of the big things with Mara. Javier and I have both worked with large production environments. We've both worked with environments that we really don't want to make rapid changes on. Everything is very considered. Everything is planned out. With Mara, we were actually given the opportunity to say, just do what you think is best, and we're not going to get paged in the middle of the night because things aren't working. which is really nice, and it's an ability to do this work. But we also want to give back to the community because we have friends, we have peers, we have colleagues who are on call. So we want to go ahead and break things before they do. I want to take a second now, and I'm on the app.pulumi.com. I'm looking at my deployment here. Now, the way we've broken out Mara is by and so here's the serious deployment. I have a lot of stacks. You may not have this many. I'm not really good at cleaning up after myself, but this is the stack that's running right now. Josh, are there anything you want to highlight on this?
Yeah, sure. So this is the Pulumi service, and so yeah, we can really just go through the tabs. So in the Pulumi service, you'll see all the stacks that you spun up either as an individual or as part of your organization. Within there, you can see the outputs, so you can copy paste those if you need to. If you look at the top right-hand corner of the screen, actually, let's go. Can you jump up a level just to serious deploy? Cool. So serious deploy is the that's the project, and then within these you see all the stacks. Now this is not what you would necessarily see in like production thing. You're probably going to see something like dev QA and prod or something like that. But let's click in. So let's click into the stack Mara test 06. Cool. Oh right. So this is the overview. This will tell you what the last update was. But if you go to the activity tab, you can see all the changes that happened in the stack. So at some point we spun it up, it added 43 resources. That's what the plus 43 is. You can see the git commit that's linked to. You can see the branch that it's on. That's the 4EF at the bottom and the kick fix. You can see an update number 2, Jason tore it down. And then in update number 3, brought it back up again. And then if you click into the details there, you see that you actually get this is what you would see if you weren't using the automation API. Now you can certainly get this output by using the automation API, but if you would just use the raw like Pulumi up, this is the output that you would get. So you get when you use the service, you get this like history of like who changed what and when, and then you also get to see the details. And so like not only can you see like the summary output, but if you click the diff, which is not going to be the easiest to read, but it'll give you like very, very detailed level of like what attributes changed on what resources. Now, because this was a Pulumi destroy followed by a Pulumi up, everything's going to be new. But if let's say you just change something about a Helm chart or a Kubernetes resource, maybe you change the number of replicas in a replica set, that would be highlighted there in that diff. In addition, if you go to the resources tab, this shows you all the resources in the stack. And if we scroll, you can see that there is actually the capability with those little links on the right-hand column that will open those things in the dashboard. So like if you, if you're like creating like a VPC in AWS, you'll see links to like jump to the VPC or the subnet or the route table. It's really, really useful. You can see here that like this stack actually references other Pulumi stacks, so you can like jump to that stack in the Pulumi service. Also super helpful. We have a question of what's graph view. Let's click on it and find out. So graph view gives you the dependencies between all of your the resources. So at the top or on the left hand side, you can see that everything is kind of under the stack. That's normal. That's just kind of how Pulumi works. But then you can see like, hey, like, oh, that config group, the config file belongs to the config group and things like that. So that's what GraphView does. So yeah, I think that's everything. Let's click on settings, see if there's anything interesting going on there. No, that's kind of like that's very much like the danger zone in like a Git repo. It's like where you like rename stuff. And then real quick, we can hop to the dashboard. So the dashboard gives you an overview of everything that's going on either in your individual account or like in your team's account. So you can see like, hey, what stacks have changed recently? How many resources do we have? If you scroll up a little bit, you can favorite some of those stacks if you have a lot of stacks in your organization. And also in the top right, you can see that you can request access for Pulumi deployments, which is a new feature of the service. So, go ahead and check that out and request that access. And that is all I have to say about the service for the moment. I'm going to check the chat. I do not see any pending questions specifically about the service. So I'm going to disappear now.
Thanks, Josh.
I do want to, before we move on from this, I do want to say that, Josh showed us the diff of what's torn down and what started up. And that was one of the welcome, again, as a developer who is not fluent in Terraform, coming to Pulumi, that was nice, is that I find the diffs that you get when you do a plan from the command line, those diffs that you get are a lot easier to parse, at least for me, going into this. So that was a nice surprise, being able to see that, and then having it all up there in the service to look at after the fact is a really nice feature.
Thanks, Javier. So one more thing I want to go into, we've talked about a bit, is the pluggability of the Mara project, and specifically around observability. And so we've tried to make the directory structure make sense. Infrastructure projects live under infrastructure. Things that just deploy into Kubernetes live under Kubernetes. And one of the things that lives under Kubernetes are our log agent, our log store, and observability. And this is a Sumo Logic integration that we've done recently, within the last week, to kind of showcase how we can rapidly add a project in Pulumi to change the complexion of Mara. And I'm actually going to go and bring up the code here. And this code is not very long. What this code does, and I think one of the strengths of Pulumi, which we use throughout the Mara project, is I can deploy things using native SDK calls to the Pulumi SDK. I can deploy things using YAML manifests, which we do in several places in this project, or I can deploy things via Helm charts. So in this case, Sumo Logic has a Helm chart that we use to deploy. And all this does, this code figures out where the Helm chart is. We have some information here that we use to figure out where to pull it from. And then down here, we deploy it. So to get from Mara using Elastic, FileBeat, and these other things, we're able to put Sumo in relatively quick. And then we just made a change up in the automation API to tell it to look for a flag telling us to deploy Sumo. And this is this is kind of the way we've been deploying Mara and adding in features. We'll do a feature branch. So in this case, here's the Sumo Logic integration preview, and it'll walk you through and tell you, you want to do Sumo Logic, here's the steps you need to take. As we move forward, we're going to be doing things like removing the complexity of trying to figure out which pieces to pick. So when you run that convenience runner script, it'll go ahead and prompt you, what do you want as your observability? What do you want as your application? And make it a lot more plug and play configurable for the users. Now, I saw a question earlier about talking about using Pulumi in a pipeline to get around the Apple Silicon issues. And I can tell you that we're currently using Jenkins as a way to test our deployments. And this is not an endorsement of Jenkins. It just happened to be the CI solution that I knew. But we do have a number of Jenkins files out here. So for instance, if you want to know how to deploy on AWS, you can pull this pipeline, add it into your Jenkins server, and it will deploy Mara. We spin up instances on DigitalOcean to host our runners, and this works. And we're going to go ahead and hop over to Mara, and you can go ahead and see it come up. And we do this with every release. And one of the issues that we're facing with Mara is we are trying to be as cloud agnostic as possible. And usually the things that we see break are not Pulumi, are not components within Mara, but are actually issues between the cloud providers. So we're discovering things like, Kubernetes 1.22 on 3 different clouds. It may work on 2 and not work on the third. So we have set up some Jenkins to run on this. And then you can even notice right now we're seeing a DO problem that is related to a change we made in Mara. I'm seeing some questions about GitHub Actions, Argo workflows. Again, you're looking at 98% of the Mara team right now with Javier and I. So, like, these are things we want to get to. We haven't. We do use some GitHub Actions to do things when we check code in, and we're currently actively debugging those. But these are things that we'd like to do in the future. So if anybody out there has experience with GitHub Actions, anybody out there has experience with Argo and wants to join the project and help out, please raise an issue, start a discussion, and we can talk about it. We know Mara fairly well, but some of these newer technologies, we do have to ramp up to learning them. Then I want to go ahead and show, so here is, I do have a running application out there right now. Here is our application. And again, I have a load being generated from Locust. For those of you who haven't used Locust before, it's a very simple load generator. Bank of Anthos came with it, and Bank of Anthos had it on a much older version, and it was pinned as a just run in the background. We've taken it and made it so you actually run it through the interface here. But you can do things like chart your usage, chart your response. I personally like trying to get the load to a point where things start to break and then figure out where the failure points are in Mara. One of the things we've been looking to do with Mara is use it to help benchmark things. And those could be things like our NGINX Ingress controller. It could be things like third-party things. I can tell you that when Mara reaches a certain load, we do start seeing problems with Elastic that may indicate that it needs to be tuned better. But you can go ahead and run this and see what your failure rate is. And then again, here is just pulling data from FileBeat. This is all configured and runs out of the box. So if you stand up Mara in AWS, you will be able to do all these things within the 30 to 40 minutes it takes to deploy. Javier, as somebody coming from the developer background, we've got about 10 minutes left. Is there anything you want to talk about to folks out there that may not be from the ops side like I am that might appeal to them as developers?
Yeah, I think I've gone over a lot of it. I just think that, one of the places I really see Pulumi, like we're doing this very large scale usage of Pulumi here, where we're chaining together a lot of different things to do what would normally take a platform operations team, months to architect, right? And then after that, you have the management of that, and that can be all done in Pulumi. As a developer, I haven't, gone through that experience. I haven't set up an entire platform to run a service. But what I have done is the common pattern, I come from a background of companies that use what, microservices is kind of meaningless at this point, but some version of having one team handling many services and then other teams handle other services. And one of the things that we had to do was, to give a concrete example, if I'm running a service that stores, chat messages, if I'm building a service that does like kind of what we see in the corner here with chat, and it has several databases, it might have a fast database, it might have like a spacing on the AWS thing that does that, DynamoDB. It might have a DynamoDB for recent messages. It might have something else for cold storage of old messages. It might have some S3 stuff for maybe storing images. So there's a lot of like infrastructure that's not at the platform level. Like it's not at the level of open telemetry collectors or a lot of the container registries and that type of thing, but it's infrastructure that is left to development teams to stand up, tear down, and manage on their own. And that stuff is a huge drag on development teams where they're the thing that they're good at is developing applications. They're not necessarily good at making sure that they are setting up a cloud database with the right log rotation policies, with the right security considerations, for example, secrets and secret rotation for like a, password rotation for a database and that type of thing. And so, this is looking at the Mara project. This is kind of what I wish I had, because I remember spending long sort of like debugging sessions with members of my team on Zoom being like, all right, well, if we change this Terraform thing, this might hook it up to this might hook up the Aurora database to the AWS Secrets Manager, but we're not quite sure. Let's try to read the diff. Whereas when I was first kind of onboarding to the Mara project and figuring out how to use Pulumi, it was great because I could say, all right, get me an instance of the Secrets Manager. And now I want to, provide that as an argument to the API for the database manager. And so that type of thing would have been really killer back in that context, because a lot of folks, we have folks of all different levels of experience, right? You had people who were very senior but had never worked with infrastructure, and you had people who were just out of school, and so they all know how to use a programming language. And I think that's the thing that I think is really compelling looking at this, is that those small changes that I would have to make, that I'm going to be on call for, that I'm going to be woken up about, are here. And so that's kind of the thing I take from Mara. The other pieces of it kind of just make that infrastructure, the massive infrastructure piece of it, a little bit more easy to understand. Like actually, Jason and I last night were working on something wasn't quite working. We were getting the wrong version of the NGINX Ingress controller being injected, and we didn't want that to happen. And so I'd never ventured into that part of the code in Mara, but Jason was able to pull it up, and most folks can read Python. So I'm not a great Python programmer, but I was able to read through it, and we were able to have a discussion. Whereas I think that if he were an operator showing me a bunch of Terraform, that may have gone less smoothly. And so that was one of those things where I was coming out of it like, hey, we have this Pulumi webinar tomorrow. And I actually just had this great little debugging session with Jason where I didn't feel useless. And that was a big sort of like breakthrough moment for me. So sorry if that was long, but that's kind of the general feeling as a developer I get coming to a project that's using Pulumi.
Yeah, and to add on to that, I'm not somebody you want doing a lot of development. I'll make it work, but it won't be pretty. Javier's development expertise with Pulumi, the way we structured Mara, I can bring him in and point to it and say, this needs to be different, and then he can help me figure out how to do it. I do see one question. So there's some love for Datadog in the chat. Yes, Mara can export to Datadog. It can export to Lightstep. It can export to insert your favorite visualization tooling here. It's just a matter of going through. For Pulumi, you can use the Datadog provider, and it's a matter of setting things up. So the way to add Datadog is to fork the project, create a fork Mara, create a Datadog project, do the stand up there, and then plumb things together. And that's something Javier and I and the other folks that help out can help with. It's just raise an issue, say, I want to add Datadog. Here's what I think needs to happen. And we can go through it. And this is where, being modular and being conscientious about our interfaces between components enables us to add and remove components to meet what people really want. Some people want 100% open source. Some people want open source but with enterprise features, so things like Datadog or Lightstep. And Mara's designed as kind of a scaffolding to realize what you actually want and then take it from there and build it in your production environment.
I also saw a question on TypeScript that I wanted to address, which is, as Jason said, you're looking at most of the team, and there's a lot of Pulumi code. So we don't have current plans to move things to TypeScript, but I actually, when I did I'm not a Python person, and so TypeScript was the closest thing to something I was familiar with Pulumi. And so that's where I started my my learning. And one of the things I did notice is that the Pulumi team does a good job of keeping the APIs of their various SDKs fairly consistent, like naming wise, like, things are, cased differently between Python and TypeScript. But what was nice is that I could, when I was reaching for a pattern that maybe wasn't I wanted to try to do something that I had seen in Mara, I was able to pretty easily say, okay, I'm going to find the equivalent of this, object that's being referenced in the Python code in TypeScript. And it was a pretty good experience doing that. So that's something you can do if you still want to use Mara as a reference, but don't necessarily have a lot of competency in Java, which describes me too. Sorry, not Java, Python.
Okay, sorry, was that a cue for me to say something? I'm typing away in the chat. A very, very engaged audience, by the way. Thank you so much to everyone who's attended, because the engagement in the chat has been awesome, and it's mostly things I know the answer to right away, and a few things that kept me on my toes. So great questions, everyone, and excellent participation. Also, this is a very, very deluxe Pulumi code base that you're looking at here with Mara. So this is really, really taking advantage of the productivity gains that Pulumi can give you. This would be very, very difficult to do in some of the other tools out there in the ecosystem. All right, so we have 3 minutes left, and it looks like people are still asking questions. Maybe I can answer a few of those on camera. Let's see. Oh, so we have someone asking about, that they would like policy as code. It's available as an add-on to the enterprise subscription. It's only available to business critical customers. Scott, that is feedback that we have received. And while I can't say anything definite, I'd say stay tuned. You can also use our policy as code features in local development or within a pipeline. It's just that with the right now with the business critical, that stuff can be enforced at a more organizational level. So you can, for example, apply a default policy to all stacks in your entire organization, and you get nicer integration in the service with being able to make rules optional and stuff like that. So it's a little bit more scalable, particularly for orgs that might have a separate security team that want to adjust the policy settings. But we have heard that feedback, and stay tuned, I guess. Johan says, we have a lot of Pulumi code in TypeScript in production. It's working great. Again, the types are a bit tricky sometimes. Biggest heads up is to transpile the JavaScript before publishing as an NPM package. Yes, perhaps. I do find that the TypeScript types are advantageous. Certainly, if types are bumming you out, JavaScript is an option. And while Python has types that are, let's say, suggestive rather than mandatory, you might have a better experience using Python. And I believe Python is our second most popular language, and our most popular probably among certain segments of users. So yeah, it looks like we are about at time. Any closing words from the fine people at NGINX F5?
Just want to thank everybody for the participation. The engagement was great. And if this is something that interests you, the Mara project, fork it, go to nginx.com/Mara, ask us questions. We have no ego, so if you think we did something wrong, please tell us, because we want to make this better. And it's hard. This is a community project, and we want to help the community.
That's great. So I'd like to thank everybody for giving us your attention, and hope you have a lovely day, and hope that you found this webinar useful. And also thanks to my co-hosts. You've been an absolute pleasure to work with.
Thank you so much.
So long, everybody. Be well.